Hi students, I am Prashant B. Chandran, SN Browser, Automobile Engineering Department, SN80 Adur. In this video, I am going to teach you about heat exchange between two gray bodies. That is a topic in our 5th module, radiation. Okay. We know that emissivity is defined as the ratio of actual heat emitted to maximum heat emitted. That is, emissivity is defined as the ratio of actual heat transfer and the maximum possible heat transfer. Okay. So definition for emissivity. Emissivity is equal to actual heat transfer divided by maximum possible heat transfer. That is, emissivity epsilon is equal to Q emitted divided by Q max. That is Q emitted divided by Q black, because for a black body heat transfer would be maximum. This Q max will always for a black body it is maximum. Okay. Then consider various types of bodies. That is, we know black body, white body and grey bodies. That is, for a white body, first of all, for a white body, emissivity is equal to 0. Then for a black body, emissivity is equal to 1. For a grey body, emissivity value lies between 0 and 1. For a grey body, emissivity value lies between 0 and 1. That is, emissivity 0 less than emissivity less than 1 for a grey body. Okay. Then if you consider a grey body, there are mainly two types of resistances. Okay, that is, if you consider a grey body, there are two types of resistances. They are, the first one is emissive resistance or surface resistance. Emissive resistance or surface resistance. Which is equal to 1 minus epsilon divided by A epsilon. This is the equation for emissive resistance or surface resistance. If there are two bodies, that is two grey bodies, then emissive resistance or surface resistance of the first body is given by R1 is equal to 1 minus epsilon 1 divided by A1 epsilon 1. Okay. Similarly, emissive resistance or surface resistance of second body is given by R2 is equal to 1 minus epsilon 2 divided by A2 epsilon 2. Okay. Is it clear? Then the second type of resistance is shape factor resistance or space resistance. This is the resistance offered by the shape factor or the space between these two bodies. Okay, and it is denoted by, it is shape factor resistance or surface resistance. Shape factor resistance or shape resistance, space resistance is given by R is equal to 1 by A1 F12. Okay, this is the equation for shape factor resistance or space resistance. Okay. Drawing the illustration, that is diagram for two gray bodies. First of all, first body is body 1, then second body is body 2, this is MC for the first body EB1, MC for the second body EB2, and drawing the resistances. First R1, then R, then R2. This is R1 is equal to 1 minus epsilon 1 divided by A1 epsilon 1, and R2 is equal to 1 minus epsilon 2 divided by A2 epsilon 2. We have marked both the surface resistances. Then shape factor resistance R is equal to 1 by A1 F12. This is a diagram. Next, our aim is to find out the heat transfer from 1 to 2. That is heat exchange by radiation is given by Q12 is equal to EB1 minus EB2 divided by the total resistance, that is R1 plus R plus R2. We know that EB1 equal to sigma into T1 raised to 4 minus T2 raised to 4. Sigma into T1 raised to 4 minus T2 raised to 4 divided by substituting the values for R1. It is 1 minus epsilon 1 divided by A1 epsilon 1 plus R1 by A1 F12 plus R21 minus epsilon 2 divided by A2 epsilon 2. This is the equation for heat exchange by radiation. Thank you for watching this video. Have a nice day.